Let's start. Okay, before we get started, just keep two things in your mind always. What I say in every video, if you already know it, you can skip it. First is that DSA questions are not hard by nature. What makes them hard is not knowing the trick behind them. And if we know the trick, the problem becomes easy. And the second is, if you ever feel stuck in a question, don't beat yourself. Especially when you are new to the DSA or new to that particular topic, it's completely okay to watch this solution first, which eventually will help you to recognize those patterns and build intuition. So be kind to yourself, trust the process, and keep going. As always, we'll begin by understanding the question and what's given to us and what we need to find out. Okay, let's understand the requirement first. What the question says is trapping rainwater. Given n non-negative integer representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So as you can see in the diagram, we have some bar and we have some water on each bar trapped. And in the input, we have an integer representing the height of the bar and the output, which is the sum of all the water trapped on each bar. Hope you understood the question, and if not, feel free to pause the video and take your own time. Okay, now let's see how we can approach it. So, can we say that for rainwater to be trapped on a bar, there should be a bar on its left and a bar on its right with the greater height than the current bar? And we need to consider the height of the smaller bar, and also we need to subtract the current bar height for it from it to calculate the final trapped water. Let's see. Let's take an example. So what I mean is, if you see this bar is of height 1, uh, to the left the maximum height of a bar is this, and to the right this is the bar of with maximum height 3. So we need to consider the height of the smaller bar, which is 2, and we need to subtract the current bar height also 1. So at last, what we'll have is the trapped water on that current bar, which is 1. Likewise, we have to calculate all the trapped water on each bar. Okay, so to summarize quickly, we need to just figure out the maximum left and the maximum right bar height till each bar. And for that, what we can do is maintain two arrays, one for storing the maximum left height and another for storing maximum right height till that index. And at the end, we can check for each bar one by one and see whether we have a bigger bar to its left or right or not. So let's quickly visualize the final logic. Okay, so we have the code snippet handy with us. So let's see line by line what we are doing here. So we are declaring the input, we are calculating its length, then we are declaring the result, then we declared two arrays, one for maximum left height, one for maximum right height, then we are just populating those two arrays. For maximum left height, we are starting from the left, and for maximum right height, we are starting from the end. Okay, and at last, what we are doing for each bar, we are checking one by one whether we have a bigger bar to its left or right or not. So if you take this example 0, 1, 0, 0, 2, so you can visualize here in the right side we have four elements, and if you see the first bar, we don't have any left bar which is greater than the current height. Same for this. We have the current bar of height 1. We don't have any bar in the left side which have more than height. So we ignore both of these. Now if we come to this, we have both left plus the right bar which has more height than this. So we take it and subtract the current height of the bar and add to the result, which will be 1. So at last bar is 2, but we also don't have a bar to his left or to his right which has the more height. So again we ignore it. So at last the result will be 1. So hope you understood it, and so that's all. You can analyze it, and in case you have some doubts, feel free to reach out in comments.